Today, we're going to talk about an adorable and not well-known species called the pink fairy armadillo, endemic to central Argentina. These armadillos are very small and are almost exclusively fossorial mammals, only coming above ground at night to forage. This makes studying them quite the challenge. One of the main problems in pink fairy armadillo research is that it is extremely difficult to study the movements of fossorial animals. Movement studies are particularly important because they allow us to understand behaviors and responses to environmental changes within a species. Even though there are no studies designed to research the movements of pink fairy armadillos, we will suggest a few methods we believe could work, based on studies done on similar species. Ground penetrating radar is a process in which electromagnetic waves are transmitted into the ground using specialized equipment and are then sent back when the signal hits a disruption. This is done by walking a scanner with an antenna along the ground, producing 2D and 3D images. There are many different makes and models for a variety of substrates. This method provides a high-resolution image of below-ground structures, and as such, has often been used to complete mole tunnel surveys. It is minimally invasive, a benefit for an acutely stressed animal like the pink fairy armadillo, and has high-speed data collection abilities that speed up research capabilities. However, one must consider that GPR is very expensive, averaging between $14,000 to $100,000, and requires major training on operation and data analytics. While this method does well at giving images of the structures below ground, this does not directly correlate to a species' movement habits, so GPR would only be part of the solution. Micro GPSs are tiny devices that record and store location data at a predetermined interval. Usually under 15 grams, they're often used in small-bodied terrestrial animals in forms of collars, implants, and attachables. These GPSs can upload data remotely, typically via satellite, and can also be collected using a receiver. Micro GPSs provide increasing opportunities for collecting GPS location data on small species that burrow, and provides efficient movement information without actually having to monitor the animal. Implants increase the survival rate of armadillos because collars can lead to injury and behavior changes. They also provide long battery lives, reducing the need to go out and recapture. Pink fairy armadillos are rarely observed in the wild. Many locals even think in their fairy tales, which makes them hard to capture in the first place. They're also extremely susceptible to stress, making handling them for too long dangerous. Many GPS devices require satellite signal for data upload, which is difficult for fossorial species that spend most of their time underground. VHF stands for Very High Frequency, which is a form of radio telemetry. The transmitters emit a high-frequency radio pulse, which is picked up by a receiver so that the tracker can tell the direction and proximity to the animal. These transmitters can be fitted to the animals in multiple ways, including by use of a collar, an external tag, or being glued on. VHFs can also be surgically implanted, which helps in small fossorial animals, such as the pink fairy armadillo, because the action of burrowing often removes external trackers. The advantage to VHF is that they're relatively low cost. They have operating life of up to 3 to 5 years, and implants can provide an added benefit of measuring body temperature, heart rate, or other physiological parameters. In contrast, this method can be labor-intensive in that a lot of field work is required. Weather can limit the functionality of satellite-based systems, and the pink fairy armadillos are hard to capture because they're rarely seen, and when captured they can become fatally stressed. Dr. Mariela Sabrina conducted a 13-year study in Argentina to capture one of these animals and never even saw one. We recommend using VHF implants and telemetry to track the almost exclusively fossorial species. This would be done by scanning for the animal on the ground to detect them below the surface. When coupled with a microhornet GPS implant, the smallest GPS implant to date, location data can be easily collected when the species is above ground foraging at night, without having to worry about human disturbance. Combining these features is the best option because GPS alone has difficulty detecting the species below the surface. This method does require a significant amount of manpower and time, but the implants are cost-effective and can have long battery lives, giving the opportunity for long-term studies to be done. It also doesn't always require recapturing the animal, which benefits our target species. Another thought is that this method could also be coupled with a geofencing to alert the surveyor if the animal crosses a boundary. We'd like to give credit to all our sources used to create this video. If you have any questions or comments, please feel free to post them in the comment section below. We look forward to chatting. Thank you and have a wonderful day.